When it comes to current models in physics, the common thread holding them all together is the interpretation of motion as the cause of cosmological redshift. In each standard model, whether it be the Big Bang, relativity, or quantum mechanics, each are built with acceptance of the expansion of space which results from this train of thought. This analysis is like pulling weeds. If we do not remove a weed at its root, it will grow back. If we remove it at the root, though it may still be living, it begins the process of breaking down into its constituents once it no longer is rooted. In the same way, differing concepts within physics act as separate branches of a single plant. There are many theories which involve expansion of space, but the concept itself underlies them all. In the same way as branches of a plant are removed from their source of sustenance when it is uprooted, so too do all models which depend on a given underlying explanation begin to decay towards their building block components, observations no longer combined into larger systems of interpretations when a model in science is truly uprooted. Though it may appear as if the model remains alive and well, if it has indeed had its roots removed, then it is just a matter of time before it notably decays, in the same way as a plant appears identical immediately before and after its uprooting, showing no signs of its decay except the mere fact that it has been uprooted. The interpretation that motion causes observed redshift effects on light from distant galaxies leads to the necessity of adding complexities to the models, namely expansion of space and dark energy. This strongly suggests that other mechanisms of redshift should be explored that do not need to add new features to the underlying nature of reality in order to explain the observations. In short summary of the previous video, one other such known mechanism of redshift is that of gravitational redshift. Due to the particulars of the observations made that there is an observed correlation of redshift per distance in the light from distant galaxies in all directions, there's only one possible way that gravity could cause the observations we see. That one single object is causing the redshift for the light from all distant galaxies. We left that video off asking if even this could produce the observations. In order for one single object to be capable of having this degree of influence, it has to be vastly larger in mass than even galaxies. Before we approach this issue, we can just suppose that such an object can exist and therefore may, and instead consider if even this scale of object would in any way be capable of producing the observations. At first glance, we can see an immediate problem. If we suppose that such a high mass object exists, then it is in one position relative to Earth. Observed galaxies, then, would be in various positions relative to both this system and Earth. If the galaxies were to be positioned in the object's direction from Earth, then the light must travel away from the object to reach Earth. If we suppose the object shifts the light gravitationally, then in such a case, we would see redshift in the light spectrum due to the light moving away from the source of gravity. However, for any galaxies in the opposite direction of the object, the light must travel towards the object to reach Earth. As a result, the object would instead create a blue shift due to the light moving towards the source of gravity. It appears then that even in the case of an object sufficiently massive to influence the light from all galaxies we see, it would still not be capable of producing an increasing redshift per distance in all directions. This, though, is not the end of the road. Thus far in this analysis, we've only considered when the light is moving in a straight line. Another effect caused by gravity has yet to be incorporated into the hypothesis. We know that gravity can cause the path that light travels to bend around the source of gravity in what is known as gravitational lensing. We have observed this in obvious ways, such as in an Einstein cross, where light traveling from a distant object is bent around an intermediary object so as to create optical illusions of, for instance, 4 separate observations of the single distant object. In these cases, though, the light must travel relatively close to the intermediary object in order to be lensed. Let us suppose, however, that if there is an object sufficiently massive enough to create observable gravitational redshift effects in the light traveling from all distant galaxies, that is also sufficiently massive to influence the direction of travel of the light from these galaxies. The degree to which it may be able to bend light should then be considered. If it bent light from distant galaxies only a little, then we would have the same result of a dichotomy of half redshifted and half blue-shifted distant galaxies, and thus even in this instance it still could not produce what we see. However, if such an object existed and were sufficiently massive so as to bend the light more, so much so that it could literally cause light from every galaxy in its region of influence, regardless of the direction the light is shining, to ultimately travel directly towards the object, then we arrive at some very interesting possibilities. Before we get to those, we have to consider what might happen to light if it approached such an object. At first glance, it may appear that even if such an object did exist and were capable of bending light to it on such a high degree, then it would simply consume all light that comes near it. However, it is important to recognize that all systems function the same. We can look to other systems and consider how they function when analyzing how such a theoretical system may function as well. In particular, there are particles known as neutrinos, which we have built observatories on Earth to monitor. What is most intriguing about this is that these observatories are not on the tops of mountains, nor are they in outer space, but rather they are built deep underground. This is because these particles are capable of physically passing through the Earth. If we suppose that this theoretical object perhaps is also penetrable by all light from galaxies in this same way, so as to pass right through it, then we can ask what would happen next. As the light were to pass the center of gravity of this object, it would then no longer be pulled in its direction of travel, but rather the direction of the pull of gravity would reverse. As a result, it would continue to travel away, following its momentum, but as it traveled, it would be redirected back towards the center of gravity once more. Such a path of travel would be capable of occurring over and over, producing specifically a figure 8 orbital pattern. In this particular case, there are several very important considerations to then make. Firstly, though we have followed several steps of supposing, we have arrived specifically at a geometric arrangement and a description of interactions that would in fact produce increasing redshift per distance by gravitational redshift. If we consider light traveling in a figure 8 orbital about an object in this way, where it is gravitationally shifted during its travel by the object's gravity, then we can consider each loop to determine how it would be influenced. During a given loop, the light would travel outward a given distance and inward the identical distance, and thus the cumulative redshift effects for each time the light passes through a loop would be zero from this motion. However, it also must move from one side of the loop to the opposite side. As a result, it also has an orbital motion which at all points is directionally away from the central object. Therefore, the light would be gravitationally redshifted per distance. As it is from one single object influencing the light from many galaxies in this way, the redshift between all distant galaxies would be correlated. And moreover, light traveling short distances from nearby galaxies would not be exposed to the gravitational influence for extended periods of time, and thereby would not yet develop the correlation of redshift per distance as seen in more distant galaxies, thus also matching our local group observations of dichotomy. Most telling, though, is the figure 8 orbital shape itself. Not only does this provide an explanation for how gravity could cause the redshift observations of distant galaxies, which importantly removes any need for the introduction of expansion of space or dark energy into interpretations, but also it goes even further in narrowing the underlying foundations of physics. This is because the figure 8 orbital, which is the result of gravity, exists everywhere in nature. We have seen it countless times, but in these cases, we have called it something else entirely, an electromagnetic field. In every instance, these fields are produced by orbital flows of particles in the infinite array of the cosmos, which travel like a river in this way, leading to our observation of such a field. Thus, this approach follows logic and reason in giving more specific and narrowed exactness by providing simultaneous answers to both how gravity causes all distant redshifted galaxies, as well as showing how gravity causes another fundamental force. In physics, fundamental forces are said to be causeless aspects of nature. However, as we see here, it is clear that gravity causes electromagnetism.